Hello everyone and welcome back to another video. Today we're going to talk about the M1, M2 linear measurement outcome. Some of the key ideas in this outcome involve the metric and imperial units of measurement, as well as how to apply proportional reasoning and unit analysis to convert between the two systems. Before we get started today, let's consider some reasons why we might want to be able to convert between the metric system and the imperial system. Living in Canada, we use a combination of both systems. For example, we look at speed typically in terms of the metric system. We will measure everything in kilometers per hour. When we start to look at something such as distance, it starts to change. If it's your height, we tend to measure in feet and inches, which are imperial units. If we're looking at long distances, we tend to look at metric units, such as kilometers. If it's related to work, we typically use imperial units, such as feet and inches in construction work. For everything else, we tend to use the metric system. We can also consider temperatures. If it's something used for baking or cooking, we tend to use degrees Fahrenheit, which is part of the imperial system. For almost everything else, we're going to use degrees Celsius, which is going to be the metric system. If we're thinking about your weight, we typically tend to go with pounds here in Canada. If it's very heavy, we'll use something such as kilograms instead. One last area where we might want to consider the difference between the imperial and metric systems is volume. When we think about something such as milk that we buy at the grocery store, we can buy them in 500 milliliter quantities, 1 liter, or even 4 liters. But once we start to use milk in a baking recipe, we tend to measure it in cups and spoons, which are imperial units. So you can see that there are a number of reasons why we should be able to understand the relationship between the two different systems. The metric system of measurement, also known as the international system, is used by nearly every single country around the world except for a handful. This system is going to be based off the idea that every preceding or succeeding unit is going to be either 10 times smaller or larger than the current unit. So if we're looking at 10 centimeters, 10 of those will be making up 1 decimeter, and 10 of these decimeters will make up 1 meter. The nice thing about the metric system is that each one of them has a unique prefix that makes it easy to identify where in the metric system each unit lies. If we're thinking about the prefix kilo, this represents 1,000. So 1 kilogram is going to be equal to 1,000 grams, and 1 kilometer is going to be equal to 1,000 meters. Although there are a number of different units in the metric system, we're only going to be exploring units of length in Math 10C. The most basic unit that we can take a look at is the meter. Smaller than that will be our decimeter. Even smaller will be your centimeter. Then we end off with the millimeter. Going in the opposite direction, we can see here that 10 of these meters will make up a decameter. 10 of these will make up a hectometer. And then 10 of these will make up 1 kilometer. The way that the metric system is set up makes it very easy to move within units in the metric system. If we're trying to go from a larger unit to something that's a little bit smaller, we're just going to have to move the decimal point to the right, or we're going to multiply by 10 for every unit to the right that we're moving. On the other hand, if we're going to move to a larger unit from the right to the left, all we're going to do is we're going to move that decimal point to the left, or we're just going to divide by 10 instead. Let's take a look at an example where we would move the decimal to the right. If we have 150 meters and we wanted to convert this into centimeters, notice here that we have to jump once and then twice to go from meters to centimeters. Doing so will result in us multiplying by 10 twice because we have 2 jumps. So we can visualize this as 150 times 10 times 10. Which gives us a grand total of 15,000 centimeters. Notice that the 10 times 10 can actually be shortened into 10 squared. The second way that we can visualize what's happening here is because we jump twice, we move 2 units towards the right, we're going to go ahead and write out the 150 meters as 150.0. Is move this decimal 2 units to the right. Now what I tend to tell my students is each of these little jumps is kind of an egg holder. So there's room for one more egg here. And we can see here that we have a grand total of 15,000 centimeters. So either method will get you to the exact same place. If we were to use an example going in the opposite direction, let's use 1,457 meters. And we want to convert this into kilometers. We can see here that moving in the opposite direction, we would have to jump once, twice, and then 3 times. So for us, this really means dividing by 10 3 separate times. So we can visualize this as 1457 divided by 10, divided by 10, and divided by 10 one more time, leaving us with 1.457 kilometers. Alternatively, we can simply move the decimal point. So I'm going to rewrite the 1457 as 1457.0. And all I'm going to do is, because we jumped 3 units to the left, we are going to move this decimal 3 places to the left. So it's going to end up right there, and we will end up with 1.457 kilometers. So once you get used to the idea of moving the decimal point either to the left or to the right, converting within the metric system is actually quite simple. Here you can pause and then take some time to work through the practice problems on your own. Once you've completed your work, unpause and double check your work. One thing that's very useful to know about when it comes to measurements is something called a referent. We define a referent in this outcome as something memorable used to estimate a length of measurement. For example, if we're looking at something such as the thickness of a dime, we can use that as a referent for 1 millimeter. Here you can pause the video and think about some possible referents for each of the following measurements. Some referents might be a little bit more unique to yourself, while others might be a little bit more universally known. Once you have a few examples listed under each measurement, you can unpause the video and see what examples I came up with. Now let's switch gears from the metric system over to the imperial system. Although Canada is a country that mainly uses the metric system, we still tend to use imperial units in certain situations. As we explained earlier, we can still use imperial units such as feet and inches to talk about our height, or degrees Fahrenheit to talk about temperature. Now, in the world, there only remains 3 countries that actually use the imperial system as their main system of measurement. That includes the United States, Liberia, and Myanmar. Now, objectively speaking, the imperial system can be a little bit trickier to navigate as a newcomer. When we take a look at some common measurements, we see that we have one of the smallest units, the inch. Then we have a foot, which is made up of 12 inches. Going a step up from that, it gives us a yard, which is made up of 3 feet or 36 inches. The biggest step up after that is going to be 1 mile, which is equivalent to 1,760 yards or 5,280 feet. Now that we're working with a new system of measurement, let's come up with some new reference for the following lengths. We have 1 inch, 1 foot, 1 yard, and 1 mile. Pause the video, come up with some of your own unique ideas, and then unpause to see which ones I come up with. Again, some of the reference that you come up with will be quite unique to you, but use the ones that I've listed as a good reference point. Let's take a look at 2 methods that we can use to convert from one imperial unit to another, the first being unit analysis, and then proportional reasoning. Looking at our example here, we want to be able to convert 23 feet into yards using both methods. We want to first leave the answer as an exact value, and then as a decimal to the nearest tenth. Let's start off with proportional reasoning since we learned about it in previous grades. First of all, we want to understand what a conversion factor is. On the previous page, we learned that 1 yard is equal to 3 feet. So this right here would be an example of a conversion factor, just something that tells us what one of a certain unit is equal to in something of another unit. Now looking at our question here, we want to start off by using our conversion factor. Since we know that 1 yard is equal to 3 feet, we want to be able to write this as a fraction. We can start off with 1 yard per 3 feet. Now, since we want to set this up as a proportion, we want this to be equal to whatever we are starting off with. So in this case, we have 23 feet. Now, the question that we typically get is, how do I know if I put my yards or my feet on the top or the bottom? Well, if we look here, we can see that we have our yards on top and then our feet on the bottom. This means that we need to make sure that we have yards on top and then feet on the bottom. This is going to be really important for later on. So taking a look at our question, since we have 23 feet, we want to be able to put that on the bottom. And then we have X number of yards up top. Once we're at this step, we want to go ahead and drop our units. Rewriting our equation, we end up with 1 over 3 is equal to X over 23. What we have now is a linear equation that we can solve by cross multiplying and then dividing. So we're going to first multiply 1 times 23, which gives us 23. And then we're going to multiply 3 times X, which gives us 3X. Now to solve, we want to go ahead and divide both sides by 3. This leaves us with 23 over 3 is equal to X, and this will be my exact value. If we were to actually put this into our calculators, we would end up with 7/6 repeating, which ends up rounding to 7.7 yards. Looking at unit analysis, we want to start off with the 23 feet. What we're going to do is we're actually going to put this 23 feet over 1. The reason won't be immediately apparent as we're going to actually explore this a little bit later on, but for now we're just going to keep that 1 as a placeholder to remind us that we can pretty much divide anything by 1. Now the next part of this involves us multiplying by our conversion factor as a fraction. What that means is I'm going to put my fraction right here. We're going to multiply. And now the tricky part is determining where does the feet go and where do the yards go. In our previous example with the proportional reasoning, we put yards up top for both, and then feet went on the bottom of both fractions. As a lead-up example of what we want to do, let's imagine we had something such as X divided by 3 is equal to 5. We might ask ourselves, what do I have to do to get rid of this X getting divided by 3? Well, in this case, we would multiply both sides of the equation by 3. And that way we can actually factor out the 3 from both the top and the bottom here. The same idea exists when we're trying to figure out if the feet goes on the top and the bottom. Since we're trying to get rid of our units in feet, we want to put feet here on the bottom, which means that our yards has to go on top. What's next is for us to determine which numbers we're going to put where. Since we know that 1 yard is equivalent to 3 feet, we're going to make sure to put 1 yard up top and then 3 feet on the bottom. Now, since we have feet and feet on both the top and the bottom, we can actually get rid of our units here, and we are left with the one that we want, which is the yard. Now, since we are really just multiplying fractions, we're going to multiply across the top in the numerators, and then we're going to multiply everything in the denominators and then divide our two results. So here we have 23 times 1 yard, which means that we have 23 yards. And we're going to divide this by 1 times 3, which is just 3. So essentially we have 23 over 3 yards as our answer, which is exactly what we got previously using proportional reasoning. So we can see here that unit analysis is actually quite a bit faster compared to proportional reasoning and is a little bit more useful in grade 10 since you're going to also be using unit analysis in Science 10 as well. Let's work through a couple more examples together. Here we have 4 feet will be equivalent to some sort of inches. We know that our conversion factor is 1 foot is equal to 12 inches. So let's start off with 4 feet on top, divided by 1. And we're going to multiply by our conversion factor. Since we're trying to get rid of the feet and it's on top here, we want to make sure that feet goes on the bottom. That leaves us with inches up top. Looking at our conversion factor, we know that 12 inches is the same as 1 foot. So going ahead and getting rid of our feet on both the top and the bottom, we're left with 4 times 12 inches up top. And since we're dividing by 1 times 1, I'm just going to not write that denominator over here, and we're left with 4 times 12 inches, which is the same as 48 inches. Try out the next 2 examples on your own by pausing the video and then unpause to check your work. In this last example, you'll notice that there are no direct conversions between miles and inches, so this means that we need to add another step. Before we can get started, we need to come up with an idea of what we're actually converting into. Starting off with miles, we know that we want to eventually get to inches. But in order to do so, we need to have a step in between. Looking at our conversion factors on the previous page, we can see that the most convenient unit to use would actually be feet, since we know that 1 foot is equal to 12 inches. So starting us off with 14 miles, let's go ahead and have 14 miles over 1, and we're going to multiply by our conversion factors. We know that 1 mile is equal to 5,280 feet. And since we're trying to get rid of miles, I want miles on the bottom and feet up top. So we have 5,280 feet for every 1 mile. This lets me get rid of the miles here and here. And now we have our measurement currently in feet. But that's not the end of our question just yet. We made it to feet, and now we want to convert into inches. Looking back at our conversion factors, we know that 1 foot is equal to 12 inches. So the nice thing about unit analysis is that we can actually add another step without having to restart our question or really add any extra work for ourselves. So now we can imagine that we're starting right here with 5,280 feet. And we're actually going to get rid of the feet by putting feet on the bottom and then inches up top. Using our conversion factor, we know that 1 foot is the same as 12 inches. And we can go ahead and get rid of feet and feet. So the part that might be a little bit confusing now is figuring out what to do with these 3 fractions. Well, the idea doesn't change. In order to multiply fractions, we multiply everything across the top in our numerators. Then we divide it by whatever we end up getting as the product of everything in your denominators. So taking a look at what we have left over, we have 14 times 5,280, and maybe I'll do this in brackets, times 12 inches. And it's very nice for us because we are dividing by 1 times 1 times 1. So I don't necessarily need my denominator there. So at the end of the day, once I multiply these 3 together, we end up getting 887 and 40 inches. So in order to convert between the metric and imperial systems, we'll have to refer to a handy dandy chart that we have here. If we look in the first column, we have all of our imperial to imperial conversions. In the second column, we have all of our imperial to metric. And then our third column has our metric to imperial conversions. Knowing which one to use is going to be really important, as some of them will make your life a little bit easier and some of them might add a little extra work. Let's take a look at our first example. Here we have 114 inches that we have to convert into centimeters. Looking at our chart, we have our options of this first one where we know that 1 inch is equal to 2.54 centimeters, or our third column here where we have 1 centimeter is equal to 0.3937 inches. Well, how do we know which one will be better to use? Let's try using both. So using this second column, we're going to write 114 inches divided by 1. we're going to multiply by our conversion factor that we see here. Since we're trying to get rid of inches, we want to make sure that inches goes on the bottom, which means that centimeters has to go on top. We know that 1 inch is the same thing as 2.54 centimeters. We can go ahead and get rid of inches here and here, and we're left with our centimeters up top, which is exactly what we want. So now we can multiply 114 times 2.54, and that's going to be centimeters, divided by 1 times 1. So we can go ahead, multiply our two numbers here, and we're left with 289.56 centimeters. Now, taking a look at that conversion factor in the third column, let's move our work aside and let's see what happens if we were to use this conversion factor instead. Our work is going to start off exactly the same, 114 inches divided by 1, and we're going to multiply by our conversion factor. We're still going to have inches on the bottom because, again, we want inches on the top and then inches on the bottom so we can actually get rid of those units, which means that centimeters will be up top. The only difference is now we know that 1 centimeter is the same thing as 0.3937 inches. Some of you guys will already notice what's different about this method, or rather this pathway. Here, we're going to eventually divide by something other than the number 1. We can see that we've got 114 times 1, which means that we have 114 centimeters, divided by 1 times 0.3937, which is just 0.3937, and we actually end up with 289.56 as well. While we still end up with the same answer, a lot of you guys will not like the fact that we're dividing by such a weird looking number. My advice to you would be to try to keep as many ones in your denominator as possible. It doesn't mean that you should avoid doing something like this, but it might just make your work look a little bit nicer and feel a little bit easier as well. Feel free to try out the next 3 examples on your own by pausing the video. Once you're done, unpause the video and check your work. Hopefully you'll notice for this third problem that we have a number of different ways we can arrive at the same answer. We want to go from a mile to a meter, but there's no direct conversion between miles to meters. This means that we need to add another step in between. Taking a look at my conversion factors, I've decided that I want to go 1 mile into yards and then into meters. Well, we can see that our first conversion is actually quite simple. We don't need to do much math because we know here that 1 mile is actually equal to 1,760 yards. So we've actually skipped our first step by converting from 1 mile to yards. So let's start off with 1,760 yards divided by 1. And we're going to multiply now by our conversion factor between yards and meters. We can see here that 1 yard is equal to 0.9144 meters. So since we have yards here on the bottom and then meters up top, I've got 1 yard is the same thing as 0.9144 meters. So once again, I'm trying to follow my own advice of having as many ones on the bottom as possible. Once we do that, I can get rid of the yards up top and then get rid of the yards on the bottom, leaving us with 1,760 times 0.9144 meters divided by 1 times 1, which is just 1. So dividing by 1 doesn't really change anything. So even if I wrote this down, it doesn't really change my answer. So I'm just not going to do that. And this leaves us with 1,609.344 meters. With our last example here on this page, we're actually going to use the help of our little scale from the previous pages. And we see that we are going to convert between kilometers or from kilometers into inches. So coming up with a plan here, we're going to go from kilometers into centimeters and then finally into inches. So we can see here to go from kilometers to centimeters, we're going to need to make 1, 2, 3, 4, 5 jumps towards the right. So that means that we need to move this decimal point 5 to the right. So if I were to rewrite this out, we have 0.005. We are going to move this 1, 2, 3, 4, and 5. Right there. Since we have space for one more 0, we end up with 50 centimeters. So 50 centimeters will be our starting point divided by 1. And we're going to use our conversion factor from the chart. Since we have centimeters up top here, I want it on the bottom. And then our inches will be up top. We know that we have 1 centimeter for every 0.3937 inches. I can get rid of my centimeters here and over here. And that means we're left with 50 times 0.3937 inches divided by 1 times 1. This leaves me with 19.685 inches. Here you can pause the video and then take a few minutes to practice these two questions. Unpause once you're ready to check your work. Now let's take a look at a couple of word problems. Here it says that Peter is driving from his house in Rocky Ridge to Crowfoot Arena, which is a distance of roughly 8.3 kilometers. How many yards is this? First of all, we want to identify from what unit we're converting into a different one. We see here that we're trying to go from kilometers into yards. Looking at our conversion chart, we see that there's no direct conversion from kilometers into yards, so we're going to have to come up with a step in the middle. Typically, what I recommend to students is if we can convert within the metric system first before going to imperial units, that would be the quickest. So here we're going to go from kilometers into meters and then finally into yards. So since we're working with 8.3 kilometers, and if we refer back to the scale that tells us where kilometers are in relation to meters, we would see that from kilometers to meters would actually be 3 units towards the right. So all we're going to do is we're going to take 8.3 kilometers and we're going to move this decimal point 3 units to the right. And then we're going to add 2 more zeros here, which means that we have 8,300 meters. So having completed this step, we are going to go ahead and have 8,300 meters over 1, and we're going to multiply this now by our conversion factor. So looking at our conversion factor, we have 1 meter is equal to 1.0936 yards. Since we have meters on top here, we want it on the bottom, and then that leaves us with yards up top. So 1 meter is the same thing as 1.0936 yards. We're going to get rid of our meters here and here, and we are left with 8,300 times 1.0936 yards divided by 1 times 1. When we multiply these together, we end up with 9,076.88 yards. This last section will explain why we've been dividing our initial measurement by 1. We have here our friend Zimmer, who needs to convert 50 meters per second to kilometers per minute. What conversions will Zimmer need to know to solve this problem? First of all, we can see here that Zimmer has to convert from meters into kilometers, so that is going to be our first conversion. And then our second conversion is going to be from seconds to minutes. So in order to make these conversions, we need to understand the conversion factors. We know from experience that 1 kilometer is equal to 1,000 meters, and then 60 seconds will give us 1 minute. So starting off our problem, we have 50 meters per 1 second. So you can see here that keeping everything as a fraction before helps us set up this question, knowing that we have 50 meters per every 1 second. Now it's up to you to decide whether or not you want to get rid of the meters first or the seconds first. Following our work in the past, let's get rid of the meters. So we can see here that since we have meters on top, we want meters on the bottom, which leaves us with kilometers on top. We know that 1 kilometer is the same thing as 1,000 meters. Let's go ahead and get rid of meters here and there, leaving us with kilometers on top, which is exactly what we want. Now the part that's a little bit tricky now is switching our thinking. Since we had meters on top before and we wanted to get rid of it, we had to put it on the bottom. If we're taking a look at seconds here, it's on the bottom. Now logically, what follows is that since it's on the bottom here, to get rid of it, we need to make sure it is up top, which means that we will have our minutes on the bottom. And we know that for every 60 seconds, we have 1 minute. And since we have seconds on the bottom and then the top, we can get rid of the seconds. And then we're left with minutes on the bottom, which is exactly what we want. From here, we can multiply straight across the top, 50 times 1 kilometer times 60. So that's really just 50 times 60 kilometers, divided by 1 times 1,000 times 1 minute. So that's going to be divided by 1,000 minutes. Simplifying things gives us 3,000 kilometers over 1,000 minutes. And simplifying that leaves us with 3 kilometers per every 1 minute. Here you can pause the video and try out these last 2 problems on your own. Unpause once you're finished and check your work. Hopefully you've learned a thing or two about the intricacies behind the math of converting between 2 units. If you have any questions, feel free to leave them in the comments below. Thanks again for watching, and I'll see you in the next video.